Good afternoon, student. This is the lecture unit number 1, lecture number 3. Today we are going to study the generalized measurement system. Up to previous lecture we have studied what is measurement, what are the different significance of the measurement system, then different types of measurement system, that is direct measurement and indirect measurement. Then we have studied the different types of primary, secondary, and tertiary measurement system. Okay, with the help of different examples. So today we are going to study the generalized measurement system. Now, the principal function of an instrument is the acquisition of information by sensing and perception, the processing of that information, and its final presentation to a human observer. Okay, now actually any instrument will acts as an acquisition of information. Means what? That instrument sends some signals from the measurement, and processing of that signals uh, by using the different components of the generalized measurement system, and convert that signal or convert that information into a presentable form to the human observer. Okay, so for that purpose we will have to study that this generalized measurement system. For the purpose of analysis and synthesis, the instruments are considered as a system. Okay, now after giving some input to any system, that system performs some analysis or synthesis inside that instrument, and give the result, or give some recorded form, or give some indicated form of information in the display panel. Okay, so this is the type of generalized measurement system. In generalized measurement system, there are some different components. That components are named as a element. Likewise, in this slide you can observe that block diagram is shown in the slide. Okay, in the block diagram here we can observe one circular circle, that is physical system. Just a second. Here we can observe the physical system. Okay, that physical system consists of sensor and transducer. This is the sensor and this is transducer. That sensor and transducer combiningly name as a detector transducer. Okay, detector transducer. Why it is known as detector transducer? Detection is nothing but the sensing, and second element is a transducer. That's why it is known as a detector transducer. Okay, and detector transducer work as a input stage. Okay, input stage in the generalized measurement system. Then next three elements are manipulator, then transmitter, and processing. Manipulator, transmitter, and processor. Okay, these three elements are combiningly called as intermediate stage. Okay, that three manipulator, transmitter, and processor, they combiningly work as an intermediate stage in the generalized measurement system. Then the controller, indicator, and recorder, these three elements are acts as a output stage. Means while presentation of processed or synthesized or analyzed data, these three uh, output stage component or element work as a controller, indicator, and recorder. Okay, so these three, controller, indicator, and recorder, work as output stage in the generalized measurement system. Now in every instrument, all the elements contained in the generalized measurement will be present, or more than that or less than that number of elements, depending upon the functionality of that instrument. The number of component or elements are present. Okay, so means generalized measurement system, what is the principle? The principal function of the generalized measurement system is that the acquisition of information by sensing and perception, processing of that information, and its final presentation to human observer, and by analyzing and synthesizing the information sensed by the sensor. Okay, so that is the generalized function of the measurement system. Now in the very first element, what it is saying, that stage 1 input stage, detector transducer. Okay, it senses the desired input to exclusion of all other and provides analog output. Means that primary sensing element जो आहे, what it will do, it will senses the information and in the form of analog. Okay, it is an element that is sensitive to the measurement variable. It is sensitive to the measurement variable, and the sensing element senses the condition, stage or values of the process variable by extracting a small part of energy from the measurement, and then produce an output which reflect this condition, state or values of the measurement. For understanding the generalized measurement system, we will consider the example of computer system. The computer system consists of number of elements or component such as CPU. Before going for CPU, the first component of the computer system is keyboard, mouse. These are the input component. Then CPU, and CPU, to the CPU monitor is connected. Okay, that monitor is the displaying unit, or what we can say output stage, and CPU is acts as a intermediate stage, and keyboard and mouse will act as a input stage. Okay, so that sensing element will work as a what sense of information it will from the observer or from the editor. The we will give input to the CPU by using the keyboard. We insert some word information in terms of words, in terms of numerical keys. Okay, that will be given to the CPU. Okay, and there will be, after the sensing of the element or after the sensing of the information by the through the keyboard to the CPU. Okay, what will happen, the next stage come under process, that is variable conversion or transducer element. Variable conversion means what, whatever the signals uh, coming out or sensed by the sensing element, that all the signals will be converted from one physical form to another, without changing the information content of the signal. मीन्स जी काही इन्फॉर्मेशन आपण सी पी यूच्या माध्यमातून सॉरी कीबोर्डच्या माध्यमातून फीड केली आहे सी पी यूला, सॉरी, दॅट इन्फॉर्मेशन हॅज बीन कन्वर्टेड फ्रॉम, म्हणजे एका फिजिकल फॉर्ममधून दुसऱ्या फिजिकल फॉर्ममध्ये, बरोबर आहे. अँड दॅट इन्फॉर्मेशन इज केप्ट सिमिलर ॲज इट इज विदाउट चेंजिंग द कंटेंट ऑफ द सिग्नल. म्हणजे जी काही इन्फॉर्मेशन सेन्स केली आहे सेन्सिंग एलिमेंटनी, ती सेन्सिंग एलिमेंटची जी इन्फॉर्मेशन आहे ती ॲज इट इज ठेवली जाते, जस्ट बाय चेंजिंग द फिजिकल फॉर्म ऑफ from one form to the another form, and the signal after conversion is more suitable for the purpose of measurement and control. Okay, now whatever the information converted from one form of physical form to the other physical form, that will be transformed to the intermediate stage, that is signal conditioning. Okay, आता सिग्नल कंडिशनिंगमध्ये काय होते, तीन प्रकारे त्याचं त्यावर प्रोसेसिंग केलं जाते. इट विल बी अ मॅनिपुलेशन, देर विल बी ट्रान्समिशन अँड देर विल बी प्रोसेसिंग. नाव इन मॅनिपुलेशन, द इन्फॉर्मेशन taken by the conversion element, that information has been manipulated according to the mathematical rules. Now we know that whatever the information provided to the CPU, that CPU will perform some different manipulation. That manipulations such as mathematical manipulations. In mathematical manipulations there will be addition, subtraction, multiplication, division, etc. Such type of manipulation will be performed by the CPU on the information taken from the conversion unit, okay, or conversion element. And without changing the physical nature of that information. Again, the physical nature will not be changed in the manipulation element also. Okay, now after the mathematical manipulation, that information is sent to the transmission element. Now the transmission element do the transmission of signal from one location to another location without changing the information content. Again, here the information will not be changed, just transmission of mathematical manipulation information will be takes place in the transmission element. Okay, म्हणजेच जी काही इन्फॉर्मेशन आपण कीबोर्डच्या माध्यमातून सी पी यूला इनपुट ॲज अ इनपुट दिली होती, त्या इन्फॉर्मेशनवर काय मॅथमॅटिकल कॅल्क्युलेशन्स केल्या जातात, मॅथमॅटिकल मॅनिप्युलेशन्स केल्या जातात, आणि आफ्टर मॅथमॅटिकल कॅल्क्युलेशन व्हॉट एव्हर द इन्फॉर्मेशन possessed by the manipulation element, that will be transmitted from one location to other location. Okay, and the transmission may be by a simple shaft and gearing assembly or a complicated one. So there will be some microprocessors will be there, transmitters will be there in the CPU. Okay, after that, the data processing element, it is an element that modifies the data before it is displayed on the or finally recorded. Means once that after the transmission of element from one location to another, it will be sent to the processing element, and processing element क्या करते, there will be a actual modification will be takes place in the information, and before it will be transmitted to the presentation or recorded or output stage. Okay, after that, the third stage, that is output stage, data presentation, which contain indicator, recorder and controller. Okay, in the diagram we can observe in the output stage there are three components, that is controller, indicator and recorder. Okay, so in third stage, the data presentation element, it provides an indication or a record, it provides an information, it provides an indication or a record in the form of can be evaluated by an unaided human sense or by a controller, and this stage collect the output from the signals conditioning element and present the same to be read or screen seen and noted by the experimenter for analysis. Means after means whatever the data has been processed in the intermediate stage, that information will send to the data presentation or data output stage. There data will be indicated, recorded and controlled by the monitor. Okay, means after processing we can observe the whatever the output that will be seen on the monitor. Okay, so this is nothing but the generalized measurement system. So here we can see that there are sensor, transducer in the detector, indicator, that is input stage, manipulator, transmitter, processor in the intermediate stage, controller, indicator and recorder in the output stage. Okay, so in every instrument there may be a similar kind of element present. Okay, depending upon the functionality of that instrument. Okay, and every instrument will work as the number of component present in it. Okay, so by using that generalized measurement system we can illustrate or we can study the illustration of measuring system, that is bourdon tube pressure gauge. Before actually going for the illustration of the measuring system of bourdon pressure tube pressure gauge, we will see the one video related to the bourdon tube pressure gauge. Okay, so here Okay, so in the bourdon tube pressure gauge we have studied, or we have seen that animated video. In that case, from the open end of the pressure source, we have applied the pressure of a liquid which is flown through the bourdon tube. Now that flexible bourdon tube will deflect by the application of a pressure, and the close end of the bourdon tube gauge will connected in mechanical linkage. Okay, as the bourdon tube will be deflected by a certain amount, uh, so that the mechanical linkage transmit the small amount of deflection, and that small amount of deflection will be converted into large amount of displacement of pointer through the sector and pinion on the graduated scale. Okay, uh, first the known amount of pressure is applied through the bourdon tube, and the deflection of the pointer has been checked. Okay, means what is calibration, that we are going to understand. uh, First we will have to uh, blow the known amount of pressure through the bourdon tube pressure gauge or bourdon tube. In that case, you will have to observe the deflection of the pointer. Okay, so for known amount of one bar pressure, uh, air is blown through the bourdon tube. In that case, we will have to check the pointer deflection, mark the first point, then we will have to blow the 2 bar of air pressure through the bourdon tube. Again we will have to check the deflection of the pointer, mark the pointer location, then again blow the air of 3 bar pressure, and again mark the pointer location. Likewise, we will have to make a scale by blowing the known quantity or known amount of pressure air through the bourdon tube from 1 to 10 bar. Okay, so that we will get the 10 points on the graduated scale. Is it 10 points on the graduated scale? So that we can say that we have prepared a scale of 1 bar to the 10 bar pressure on the graduated scale. Okay, now we are interested to blow the unknown pressure air through the bourdon tube. In that case, uh, what will happen? Again, the bourdon tube will get deflected. Bourdon tube get deformed, and because of that, the small amount of deflection will be given by the mechanical linkage, and a large amount of deflection is given by the sector and pinion on the pointer. Okay, so that pointer deflection for unknown pressure will be in between 1 bar to 10 bar graduated scale. Okay, so that easily we can measure the unknown pressure of air or any fluid by using the graduated scale. Why? Because initially we have calibrated the scale by using the known amount of pressure air. Okay, so that is nothing but the calibration. Okay, now, for illustration of a measuring system of a bourdon tube pressure gauge, the bourdon tube is acts as a primary sensing and variable conversion element. Then mechanical linkage will act as a data present transmission element. Then gearing acts as a variable manipulation element, and pointer and dial acts as a data presentation element. Okay, so how it will work: the primary sensing and variable conversion element. Once we blow the unknown pressure air through the bourdon tube will become deformed, and the deformation will be sensed by the mechanical linkage. Okay, that means what? Primary sensing and variable conversion element, that is bourdon tube. Now after the deflection of the bourdon tube, that deflection, small amount of deflection will be uh, transmitted by the mechanical linkage. Then the gearing and sector will be acts as a variable manipulator element, means there will be small deflection is converted into large deflection by the sector and gear or pinion. Okay, that is manipulation of element. Then the pinion is transmitting or presenting the data on the graduated scale through the pointer. Okay, so same kind of illustration is explained here. When the static pressure input signal is applied to the bourdon tube, its free end get deflects and the pressure is converted into a small displacement. Okay, hence acts as a primary sensing and a variable conversion element. Okay, the closed end of the bourdon tube is connected to the gearing arrangement through the mechanical linkage, and the gearing arrangement amplifies the small displacement, and consequently the pointer rotates through the large scale or large angle. Okay, thus the linkage acts as a data transmission element while gearing arrangement acts as a data manipulation unit, and final data presentation stage consists of pointer and dial arrangement. Okay, which when calibrated with a known pressure input gives an indication of the pressure signals. Okay, that I have already explained to you. Okay, how the calibration is done by the known pressure. By that known pressures, the scale will become calibrated. Graduated scale has been created, and sorry, when the unknown quantity or unknown pressure air is blown through the bourdon tube, it will use the exact reading for the, means it will shows the pointer location in between that 1 bar to 10 bar graduated scale, and from that we can easily understood how much magnitude of unknown pressure air has we have blown to the bourdon tube pressure gauge. Okay, so that it is nothing but the understanding of the unknown pressure air through the bourdon tube pressure gauge. Here the block diagram also represent the input, that is primary sensing element bourdon tube, variable conversion element, then displacement occurs, small displacement, then data presentation element and variable manipulation element. After that some large amount of angular displacement will be shown over the graduated scale. Okay, and which will be represented by the pointer and dial on the graduated scale. That is the data presentation stage or output stage. Understood? So this is nothing but the illustration of the bourdon tube pressure gauge with the help of generalized measurement system. So I think all of you have understood the generalized measurement system with the help of illustration of measuring system, that is by using the bourdon tube pressure gauge. So, okay, in the next lecture we will study the illustration of the pressure actuated thermometer, how it will works. Okay, with the help of that schematic diagram of a pressure actuated thermometers. Thank you. We will stop over here.